Hello everyone, I am Vaishnavi Harihar and welcome to our YouTube channel. Here I am going to explain you the convolution of discrete time signal, which is the important concept of signal science system, which is used for describing the output signal when input signal and impulse response are known. So in first step we have defined workspace for clearing. CLC is used for clearing workspace. Clear is used for clearing all the variables, and close all is used for clearing all the figures. In next step we have defined first signal, that is input signal x of n. So x equal to 1, 2, 3, 4. Nx is the index of input signal equal to 0 colon length of x minus 1 semicolon. So length of x is our 4, 1, 2, 3, 4. Length of x is 4, 4 minus 1, 3. So 0 to 3 is our index of input signal. So x of 0 equal to 1, x of 1 equal to 2, x of 2 equal to 3 and x of 3 equal to 4. Similarly, in next step we have defined impulse response. H equal to 1, 1, 1. NH is index of impulse response equal to 0 colon length of h minus 1. Similarly, as input signal, length of h is 1, 2, 3, 3 minus 1, 2, and 0 to 2 is the index of h. And in next step we have performed convolution using conv function, which is inbuilt function in MATLAB, and y is our output signal. So y equal to conv of x comma h semicolon. X comma h is used because we have to perform convolution of input signal and impulse response.
Hello everyone, my name is Anuja Savant and I am explain a second part of this MATLAB code. Here we define a index of output signal. Ny is our output signal is equal to starting index of input signal plus starting index of impulse signals column end index of input signal plus end index of impulse signal. Here we define ny is our output signal. Second, display the result. Here this is a MATLAB command for display the result. Here we write output signal after convolution. This y is our output signal. Here we plotting a signals. First we plot our input signal. Here we call a subplot. 3 is our 3 is our row, 1 is our column, and 1 is our activate first plot. Here we plot a first graph. Second, steam. Nx is our x-axis time index. X is our input signal, and fill is for plotting our first input signal. Here we give a title. So input signal x of n. Second one is x label. Here here we give a x label and y label. In our x label we give a index, and y label we give a amplitude.
Hello, I am Mohini Patil. I will explain the third part of the MATLAB code. Subplot 3, 1, 2. This command divides the graph into 3 parts and select second graph. Then stem nh, h, field. This is for discrete time signal, and this command plots the impulse response of the graph. Then title impulse response h of n. This commands gives the title to the graph. Then x label n. This labels the x-axis as n, and then y label amplitude. This labels y-axis as amplitude.
Hello guys, my name is Shravendran Patil. Now I explain last part of this code. Subplot 3, 1, 3. Divides graph into 3 parts and select the third graph. Stream of y fields Plot the output signal convolution result in a discrete form. Title output signal y of n equals to n of n into h of n. X label gives title to graph showing it is convolution output. X label of n. Label x-axis as in time index. Y label amplitude. Labels y-axis amplitude signal values. Now we complete this all code. Then we run this code. After running this code, we get three signals. First is input signal, second signal is impulse response, and third signal is output signal. So this all complete code is a discrete time convolution code. So thank you for watching this video.